Intel's dominance over the CPU market is under serious threat from AMD in both the server business and the client desktop sector. To fight AMD, Intel has put together a dream team to not only maintain its dominant position in CPUs, but also go after the lucrative GPU market. After years of stagnation, the tech giant is finally releasing a new architecture to replace Skylake, and is banking heavily on the delayed 10nm node shrink to remain competitive. The laptop market, however, has been a haven for Intel, be it with Apple machines, thin and light portables and transforming hybrids, or even with heavy-duty gaming bricks. Intel rules the laptop market undisputed, and at least here, AMD doesn't seem to present much of a threat. Yet. But there is another kid on the laptop block, ARM. And for the companies using ARM, the laptop is the Trojan horse, because their eyes are set on bigger things. The first ARM-based product was developed by the UK-based Acorn Computers in the early 80s. It was a co-processor to be used in the popular BBC microcomputer. After the tape-out period, ARM received its first CPU back from the Silicon Foundry and began testing it. When testing for power draw, the chip was connected to a power supply with an ammeter in between the two. Although Acorn was expecting the chip to be low power, they did not expect what followed. The CPU was running, but the ammeter read 0. It turned out they had forgotten to connect the CPU to the power supply, and yet the chip was still running. Astonishingly, the ARM chip was so low power that it was running through the signal inputs of the test board. It was drawing 1/10 of a watt. Although in 1984 ARM's low-power design had no significant advantages, it later became one of the keys to the success of the platform with the release of the Apple Newton, which used an ARM CPU. And just like today, back in those days, having Apple as your customer meant credibility with the rest of the industry. And even though the Newton was a commercial failure, ARM had established themselves as the go-to company for low-power chips, and soon after they would be powering the mobile phones of the largest mobile manufacturer of the 90s, Nokia. Historically, chip manufacturers and designers such as Intel, AMD, and Nvidia have always touted the increased number of transistors as a benchmark for improvements in performance. ARM, on the other hand, puts efficiency as the top priority for their designs and achieves similar or even greater performance as their competitors, but with less transistors. Less transistors means less switching activity in each clock cycle and therefore less power required. Nowadays, ARM Holdings doesn't manufacture CPUs anymore or even design them. They design the CPU cores, which they license to third parties like Apple, Qualcomm, or even Nvidia, who then use them to create their own ARM-based CPUs, adding other components as needed. Nvidia's Tegra chips used in the Shield or the Nintendo Switch, or Apple's iPhones and iPads all use ARM. Chances are you probably have a device with you right now that has an ARM-based SoC in it. But ARM is also an architecture, and the way it works is closely tied to how the ARM cores work. Where Intel and AMD use the CISC-based x86 architecture, ARM uses a RISC-based architecture. What this means in practical terms is that x86 software, like your games, don't work directly on the ARM architecture. So for a program that you use in Windows to work on an ARM chip, it needs to either be recompiled to the native ARM architecture, or it will need to run on an x86 emulator. Now, I imagine that the vast majority of you watching this see ARM products as great for mobile phones and tablets, but not really relevant for us enthusiasts. We care mostly about performance. Our CPUs run on uninterrupted power after all, not on batteries, so why should we care about ARM? I'll tell you why. Because there are 3 gigantic corporations who are doing everything they can to make ARM the main architecture for PCs: Qualcomm, Microsoft, and Apple. And with these big boys comes better software support and more powerful ARM-based hardware than what we're used to seeing on mobile phones. Before we take a look at some benchmarks and performance numbers, we should ask ourselves, why on earth is Microsoft and Apple pushing ARM so aggressively? If x86 processors work fine, why change? Sure, there's the battery advantages for mobile devices, but what about performance? Not to mention that both AMD and Intel are promising some incredible x86 products for 2019, so why take on the massive amount of work of translating all of our software from x86 to ARM? There are several reasons as to why the two largest providers of software want to switch to ARM, and some are common to both Microsoft and Apple. For Microsoft, the Windows experience on cheaper mobile devices has traditionally been poor, especially from the Windows Vista period up until Windows 8. How many of you are looking forward to spending this Christmas holiday cleaning up your family members' Windows machines, removing adware, Bitcoin miners and whatnot? On top of that, OEMs like Lenovo, HP, Dell, etc. for years included crapware in their cheaper laptops because margins were so razor thin that getting a few dollars from McAfee or having bloatware that mines data like Lenovo's Superfish actually made a difference between a laptop being profitable or not. Over the years, this made the experience on Windows laptops unpleasant and frustrating for users, many of whom, when faced with Macs that just work, made the switch over to Apple just to get rid of the headaches. How many times have you heard Mac users, especially older folks, say they don't mind paying more for a Mac because of the headache-free user experience? Macs owe much of their reputation for reliability and ease of use to the unbelievably horrible experience that Microsoft created for their Windows systems. Microsoft has been trying to tackle these problems since the Windows Vista days, and the Microsoft App Store in Windows 10 is part of the solution. By having more control over the apps that users can install, Microsoft wants to improve the overall Windows experience by cutting down on the bloatware that gets installed. The other half of the solution has to do with hardware costs. By switching to ARM, OEMs can reduce costs and make a profit even on the cheaper machines without having to include crapware and miners, thus, again, improving the overall user experience, bringing it closer to the Apple normie friendliness. Another reason for switching to ARM is Microsoft's frustration with the lack of innovation in the PC market compared to what Apple has been doing in the last decade, which has led the company to start making their own laptops, tablets, and even all-in-ones in the form of the Surface line. And although these were meant to spur OEMs to start innovating themselves, the Surface products actually turned out to be really successful for Microsoft. In my day job as a graphic designer, I've started seeing a lot of executives from the banking sector, medical, law, finance, and other areas sending me wireframes created in Surface laptops. The Surface Pen has seen a surprising wide adoption with executives of all people, no doubt thanks to these machines being company issued. The challenge for Microsoft is that as more and more users in the business sector move to laptops and tablets, they need to be competitive with Apple when it comes to the software ecosystem, the battery life, the user experience, and all the while creating a platform for OEMs to have larger margins. There is simply no way of achieving all of this with Intel or AMD. This is very important to understand. Intel's lack of innovation in this space and AMD's lack of volume capacity have heavily limited Microsoft's ability to match Apple's innovation in the last 10 years. Apple's success with the iPhone and the iPad was a huge wake-up call for Microsoft, who really missed the boat on mobile devices, and ARM was the enabler for Apple's success. And when Microsoft looks towards the future, they see new form factors emerging, like foldable phones that will create a bridge between a phone and a tablet. How long until we see a device that can transform from a phone to a full laptop? Who knows what other innovations are around the corner? Maybe a screen that stretches so that it can be used as a phone, a tablet, and even as a desktop. Microsoft can't afford to miss the boat again in the next wave of shiny gadgets, and ARM has been the enabler of the innovation that's happening in these new market segments. Now you might be asking yourself, why can't Intel just create a low-power chip similar to the ARM chips? Well, it's not for the lack of trying, and I won't get too deep into the advantages of a CISC architecture versus a RISC one, but things like AVX, DMA, and micro-ops that you might have seen in those Intel slides over the years are basically an effort from Intel to make their architecture behave more like the RISC-based one that ARM has, because in its origin, x86 is not as well suited for parallel computing, which is the way the industry is headed. Adding more instruction sets and bloat to the x86 architecture was fine when we were getting incredible jumps in performance every couple of years, but nowadays parallel compute needs that force the x86 bloat means that the code inevitably relies on more and more transistor switching, and therefore Higher power consumption. Intel's low-power Y-series chips will continue to have less cores and lower frequencies in order to conserve power draw, while ARM chips, which are already at twice the core count, can happily move on to 16 cores and beyond, while retaining the simpler instruction set that just doesn't require as much transistor switching, not to mention being less reliant on memory bandwidth. This is a simplification, and if you want to discuss the differences between the x86 and ARM architectures further, I'll be happy to explain more in the comments, and of course, if you're a patron, we can talk on Discord. So now that we understand Microsoft's motivation for moving to ARM when it comes to innovation, there's still the matter of hardware performance to consider. Looking at Qualcomm's fairly modest Snapdragon 835, we can see that when emulating x86 apps, it falls behind the i5 7154 considerably. The i5 is about 57% faster in multi-threaded workloads and over 100% faster in single-threaded workloads. However, when running native ARM 32-bit code in Geekbench 4.3, the 835 is actually faster than the i5 running 32-bit code and just a hair away from the 64-bit results. Of course, when it comes to battery life, there's no contest, with the ARM system lasting 16 hours against Intel systems' 10 hours. These tests were run on equivalently spec'd HP NVX2s, so we have comparable native performance but almost twice the battery life in regular use, and the ARM system cost $150 less than the equivalent Intel one. And this is with an ARM SoC that is almost a year old, adapted from mobile phones to run on a PC. So what if Qualcomm were to actually produce a chip specifically designed for the PC? Well, just recently Qualcomm announced the Snapdragon 8CX, a 7nm chip that will be released next summer, destined primarily for Windows laptops. Let's try and compare this 8CX with what Intel and AMD will have on offer in 2019. For low power, Intel currently have at the top of the stack the i7-8565U. I imagine this will eventually be replaced next year by a 9th gen chip, or maybe even a Sunnycove chip, but the specs probably won't change that much in this segment. The 8565U has a 1.8 GHz base and 4.6 GHz boost, with 4 cores and 8 threads with a TDP of 15 watts, although it will go up to 25 watts when boosting. The Y-series chips would probably be a fairer comparison at around 7 watts, but let's stick to the U-series ones. For AMD, Ryzen's upcoming U-series refresh is rumored to feature at the top the 3700U, with 4 cores and 8 threads at 2.2 GHz and a 3.8 GHz boost, with Vega 10 graphics also at 15 watts. AMD's advantage here will naturally be in the graphics department. While this newly announced Snapdragon 8CX is an 8-core part with 4 cores running at 2.75 GHz at 7 watts, with the possibility of being pushed beyond this frequency with a higher target TDP. It also comes with an integrated Adreno 680 GPU. There's no apples-to-apples benchmark comparison between these systems, but the current ARM SoCs like the 835 mentioned earlier and the 850 can already run the most popular games like Fortnite, PUBG, Grand Theft Auto 5, etc. at 1080p just fine, and the 8CX is supposedly 3.5 times faster than the 835 and 60% more power efficient than the Snapdragon 850. In a short period of time, Qualcomm is tripling the performance level of the first iterations of ARM chips on the PC. The 8CX will also support Vulkan and DirectX 12 and dual HDR 4K displays, so we're looking at fairly comparable specs on paper, and if Qualcomm's claims are to be believed, the 8CX will have similar performance to these competing SoCs, but with the advantage of multi-day battery life, and of course higher margins for OEMs that decide to use it. So you can see how the likes of Dell, HP and Lenovo would be interested in switching over to ARM. They can increase their margins, advertise better battery life and offer similar performance as Intel-based laptops, provided you are using native apps. In the 8CX presentation, Qualcomm strongly emphasized the chip's compatibility with Windows Enterprise, and they're working closely with Microsoft to improve software compatibility with the ARM platform. This indicates to me that the Surface line of products will eventually transition completely to ARM, although for the time being I would expect that to be Intel versions selling alongside ARM ones. Another sector where we will start to see more and more ARM-based machines is in the embedded desktop devices made for simple office work, like those cheap little Atom-based office PCs that you've probably seen at banks, retail, and many other enterprise sectors. This segment is a huge moneymaker for Intel that will also begin to transition to the cheaper ARM platform, because a lot of these businesses work closely with Microsoft when buying in bulk, and Microsoft will be pushing Windows on ARM as much as possible. Gigabyte in particular looks like a good candidate to develop a cheap platform for these types of office machines. Even in the server sector, ARM is now offering very compelling solutions. Amazon recently announced a new line of ARM-based servers, and just as I was making this video, Wendell from Level 1 Techs posted a very interesting review of an ARM-based server, which I'll link to in the video description. I spoke with Wendell about the advantages of this ARM server versus Xeon's, and from what he said, I gather that even as it stands, with the current crop of ARM server chips, you're looking at anywhere between 1/3 to 2/3 of the upfront cost of Intel servers, and obviously even higher savings in the long run when you consider how much a data center can save on its power bill using ARM servers instead of Xeon's. Power consumption is a massive consideration for data centers, so if ARM can achieve similar performance as Intel, for certain types of server workloads, ARM will start taking over the server business, and with 7nm based ARM servers coming soon, for database clusters, virtualized containers and calmer web server workloads, the increase in clock speeds of the next generation of ARM chips will offer even better price to performance value compared to Xeon's and EPYC's. So ARM is already the king of mobile phones. Qualcomm has joined forces with Microsoft to aggressively go after the laptop and tablet market. OEMs like Gigabyte and others have the doors wide open for challenging the simple office machines business with cheaper ARM solutions, and even for common server workloads, ARM-based products like the KVM one mentioned can bring enormous savings to data centers. Could things get any worse for Intel? Well, guess who else is ditching Intel in favor of ARM? This is all great news for ARM, in theory, but as we saw earlier, until there is native app support, ARM chips will be completely and utterly crushed in x86 emulation by Intel and AMD parts, and even though Microsoft is pushing for ARM adoption, it can't, on its own, get software developers to transition their apps to ARM. But Microsoft is not alone in pushing developers to natively support ARM. After a couple of years of stagnation and mediocre products, Apple surprised everyone, or at least myself, with the excellent new iPad Pro. Now, as a PC enthusiast, I'll be the first to criticize Apple for their anti-consumer business practices, their propaganda, and their ridiculous prices considering what they offer. And their hardware integration team has done some unbelievably stupid things when integrating Intel parts. Just look at the i9-based MacBook and the throttling mess that they made of it, just to point out one recent example. But even I have to admit that the latest iPad Pro is a fantastic product, with a digitizer that rivals Wacom's best, really good performance for a tablet, and all for a decent price. And guess what's inside it? An ARM-based SoC. The Apple-designed A12X inside the iPad Pro is actually faster than the Intel Core i7-equipped MacBook Pros. The A12X is an 8-core ARM-based SoC with a custom GPU that's about 30% slower than a GTX 750 Ti. So as of right now, when it comes to performance, Apple can fit a CPU on par with the latest mobile i7s and a GPU equivalent to an entry-level discrete graphics card into a really thin, battery-powered device. It's not hard to see where things are headed for Apple when it comes to their hardware, and you can see how good the performance already is when code is written natively for ARM instead of relying on x86 emulation, like with those Windows laptops we saw earlier. Within the next 24 months, we will see Apple transition their family of products that have so far relied on Intel chips to their own ARM-based custom SoCs, and that includes the MacBooks, the iMacs, and eventually even the Mac Pros. It makes sense from a business perspective because with their own ARM-based SoCs, Apple can already get the same performance as Intel with much longer battery life and at a much lower cost to build. And if there's one thing that Apple likes is reducing costs and increasing margins. So while I don't expect ARM-based Apple products to be cheaper for consumers, they will definitely be cheaper to manufacture. This obviously means higher profits and happier shareholders. Like we discussed before, software support has been one of the obstacles for ARM to contend contend with Intel in the PC space, and one of the reasons for the Windows RT spectacular failure. So you might think that the same will be true for the Apple ecosystem, right? While things on Windows are progressing slowly for ARM adoption, you can be sure that Apple already has a fully working version of macOS running on ARM in their labs. And as far as third-party software is concerned, we already know that Microsoft is working on Office for ARM, and just recently Adobe announced in a blog post that they will be releasing Photoshop CC for the ARM-based iPads. As interesting a product as the iPad Pro might be, it's not going to have enough of a user base to justify a full version of Photoshop. Adobe is doing this because internally, it's already transitioning the full Adobe suite to run natively on ARM, because macOS will be ARM-based within the next couple of years. And whether you like Apple or not, in this industry, Apple leads and others follow. With macOS running on ARM and the most important third-party apps like Chrome, Office and Photoshop transitioning to it, ARM's biggest challenge in conquering the PC market, app support, will be greatly alleviated by Microsoft's and Apple's push for the platform. Now, I'm well aware of the hate that Qualcomm gets from enthusiasts. Our niche cares mostly about performance, and I think a lot of reviewers out there haven't really done a good job of explaining the potential benefits of ARM, and that the current performance problems that come from emulating x86 are transitionary. It's also easy to get scared that the enthusiast platform that we know and love will die out in favor of something we're not familiar with on the desktop. I can understand that, and as an enthusiast, I don't want my PC to become more like a Mac, and I'm sure the majority of you would agree. But the reality is, as much as we love our platform and what it enables us to do, namely gaming, the truth is x86 has stagnated and is now becoming a limiting factor for progress. It's incredibly bloated from the instruction set point of view, and we're also coming to a point in the hardware side where we can no longer just brute force progress through shrinking processors down, as Intel has done in the past 3 decades. We still have probably another 5 years of high-end desktops relying on Intel and AMD, but ARM will take over sooner than most people seem to realize. Sounds crazy? Well, think about this. In 2016, just 3 years ago, there were no Ryzen CPUs. AMD was basically irrelevant in the CPU market. Today, we're talking about 16-core mainstream CPUs, and the predictions of AMD getting 30% of market share next year are starting to sound conservative when you look at the rumored specs for their upcoming CPUs. All of that, a complete change in the desktop market in just 3 years. That's how fast things change, and the companies pushing ARM are incredibly influential. Apple, Microsoft, Qualcomm, Amazon, Google, these are market leaders, and if they switch to ARM, the rest of the market will follow, whether we like it or not. As a side note, when people say that there's no way that AMD would be releasing the next Ryzen CPUs with such high core counts because there's no need for them, what they are failing to see is that in this industry, if you get comfortable, others will come and take over. AMD have no choice but to push for more cores and higher clocks and better efficiency. AMD are also pushing towards having a mixed offering and an ecosystem with CPUs, GPUs and APUs, not to mention their semi-custom business with consoles. They are hedging their bets, and wisely so. For Intel, however, the future doesn't look so great. They have been complacent, and after they lose Apple, which will happen soon, they will lose Microsoft and Windows. Intel might have the performance advantage for now, but at the end of the day, money talks, and Qualcomm are predicting bringing to market 5nm SoCs by 2020, while Intel is struggling to bring 10nm next year. Next year, Qualcomm are tripling the performance of their current high-end chip with the 8CX. In 2 years' time, at 5nm, they might start to match the performance of high-end desktop parts. So to finish this one off, what can Intel do to remain relevant? Well, Intel can see the writing on the wall and have been taking some steps towards preparing the company for the challenges ahead. They've assembled a great team to come up with solutions, and just last week they had their architecture day with some very promising announcements. They are promising 10nm products in the first half of 2019, and unsurprisingly, laptops will be the first to get 10nm CPUs. AMD is bringing these amazing CPUs to the desktop, and Intel is focusing on laptops? Well, hopefully now you know why. Intel knows that ARM-based chips are becoming more and more enticing for OEMs, so the stuff that Intel promised at their Architecture Day was not just to appease shareholders or to let consumers know they will compete with AMD next year. This was Intel attempting to show Apple and Microsoft that they will continue to be relevant, probably too little too late, and I honestly doubt that Intel will have the fab capacity to ship these 10nm laptop chips in volume next year, so things are looking dire for Intel, and ARM is waving the final nail in the coffin that Intel built for themselves. This video was made possible by my awesome patrons who, in addition to helping this channel exist, also get exclusive access to my Discord server. Consider joining them for just $1 per month. If you can't contribute financially at this point, then please give this video a like and share it on social media, as that really helps. Thanks for watching, and until the next one.